Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
The third and final speaker for this session is Bora Baron, a researcher in the eScience group of Microsoft Research. The title of his talk is SciScope, a data discovery and retrieval tool for environmental science.
Hey, you know me as the person who couldn't provide Jane Hunter with a virtual web service key. And today in my talk, I'll try to convince you that I can help you find scientific data. And hopefully convince you. Okay. Okay, first, let me start with the question and explain you why we're trying to do this. And one thing we think we agree upon is that scientists often need to work with data from multiple data sources. And here are the reasons why we think so. If you have multiple data sources, you have a data variety. For example, just to do the simple plot, a scientist in the US needs to get data from U.S. Geological Survey, also NOAA, National Weather Service. Moreover, if you want to get better spatial coverage, it's better to work with multiple data sources. In these two maps, you see the data coverage by Environmental Protection Agency's Storage and Retrieval System to the left, and to the right, we have Texas Commission on Environmental Quality's coverage. So you can see that EPA doesn't have that many sites in Texas, but if we can combine these two maps, you will have a more complete coverage. And it's not really easy to make guesses on the overall coverage because specific locations have better coverage for specific agencies. For example, STORAD has very little sites in Texas, as I mentioned, but it has a lot more sites in Florida compared to USGS, but USGS has a lot more data in Minnesota compared to EPA. This also has impacts on temporal data coverage because sensors come online and offline depending on the funding situation. And here I'll present you my case in Chesapeake Bay. This is a search for nitrogen data, and you see the results for the period 1957 until 77. And blue sites indicate USGS observations. And if you fast forward in time to 77 until 2003, you start seeing some red dots and red rectangles. And rectangles are EPA sites, and circles are Chesapeake Bay Information Management System. And you can see that there are only one or two USGS sites. And if you keep going, 2003 until 2007, now you don't have any triangles. It's all Chesapeake Bay Information Management System. So if you want to get long data coverage, you will have to get data from all of these data sources, or at some point you will be able to find no data. Yeah. So let's say we are working with multiple data sources, and this is our scientist who's trying to do the plot that I showed in my second slide, rainfall versus runoff in Russian River Basin. And you see the two data sources, NOAA at the top and USGS at the bottom. First, the scientists need to find the locations where there are measurements in that area, like sites, sensors. And today, it's not possible using these two data sources. You need to know the codes that describe individual data sites. So first, he uses a proprietary GIS tool to locate the data sites, then goes to each site using those codes, and similar codes for observations, and gets data into completely different formats. And he has to put them together so he can run his analysis. And 1 month later, of course, time goes by, there's more rainfall and runoff data. He goes through the process again. So how can we solve the problem? So we need some kind of a search engine that will allow you to search all these data repositories very simply, as if they are one database. And since we have a geospatial component, it has to have some GIS abilities. And since these are all different data sources, they will have different terminologies, different database systems, so we need some kind of mediator. And we have a prototype of this kind of an application, which is SciScope. And here you can see a similar search, Russian River. Just click on the map and find the locations, and you type in a keyword, and you get the results. And the results are always in the same format, regardless of the underlying data source. And 1 month later, you just get the data. You don't have to do it again. So to make it more clear, I think I can give you a little video. I could have done a real live demo, but it's safer to have a video. But the site is online. You can give it a try if you want. It's www.sciscope.org. And did I just say the videos were reliable? Okay, here it goes. So this is a SciScope interface. And we have layers that you can interact with. For example, at the moment we're interacting with geology layer. And you can see, hold on. Here to the left, you can see the available layers. And depending on what you click, you will get some information about that area. So let's select the basin, which requires us to activate the watershed layer. I just select the Great Salt Lake Basin. You can set the transparencies of the layer. You can rearrange them by dragging and dropping. And now we type a keyword, just like a web search. Then set a time frame, because we're interested in data collected in a certain time frame. And that's enough to start a search, because now we know where we are looking for data, what time frame, and what concept. And now you found data. And the nice thing is we have an underlying knowledge base. So you typed in insecticides, and it says you can expand your search using the term pesticides, and here you have some options to narrow down the search. And these little orange dots indicate that we have definitions for each of the terms. And here is a site. If you click on the site, you will see the observations that are available. These are this is the entire list of observations available at that site. And for simplicity, we have the things that are related to your search, a subset of that entire list. And that was a cluster of 2 sites. So let's have a look at this definitions. It's a toxicology network definition. And there's a link. If you click on it, it gives you it points you to EPA substance registry, where you can find information about the chemical and legislation about use. You can see EPA registry. And let's narrow down the search to aldrin. Just click on it. Now you have a subset of the data. And here it says, you may also be interested in another chemical. And why? Because the aldrin is a degradation product of aldrin. So we have some kind of semantic support in the system. And if you want to get the data, you just add it to your cart. It takes a couple of seconds, and you're ready to download. And you get the data in an Excel spreadsheet format. So let's try a different search this time for pathogens. So there are about 19,000 different observation types in the system and 1.7 million sites. And here we have some information about this organism from Center for Disease Control, and it gives you the taxonomy information from the Integrated Taxonomic Information System. And if you want to download the data, click on the site, just select the measurement, and you get it. And here in this demo, I'll also like to show you a new feature that's not on the website yet, but you may find it interesting. we had a lot of questions about sites that have really few measurements, because I'm talking about 1.7 million sites, but bottle samples also add to that number. So you can have a site that has 5 measurements, and a lot of scientists are interested in sites that have really long data coverage. So we have these extra filters that you can add, like observation count, publisher, statistics type. Is it daily maximum, or instantaneous measurement, or weekly average, moving average, etc. So, and it's really context sensitive. So if I say observation count, since it's a numeric field, I will get options like less than, greater than, equals to. And I can just select units and type in a number and add it as a filter. And if I don't rely on certain publishers, I can just remove them. And you see that since it is text, we don't have less than, greater than options. And it's a multi-select, so it's a bare cardinality. It will allow me to select multiple options. And if there are too many options, you can do the opposite. I don't want this one, instead of trying to list the ones that you want. So we have not equals option. I don't have anything against Johns Hopkins. That's just one of the options. Okay, so let's have a closer look at what's happening in the background. So this is the structure of SciScope. At the bottom, we have our data sources and web crawlers on top. So the system is like a web search engine. We create indexes of the data sources. We also have some publishing tools for people who want to publish their data in the system, and some spatial ETL engine that gets maps from sources like USGS and National Atlas, so we can provide the underlying data layers. We have the database layer here, SQL Server database. We also use the spatial features of SQL Server 2008 and map layers for virtual Earth. Here we have the mediation layer that takes care of semantics, syntactic, and structural mediation. And at the top, we have data retrieval tools. There could be desktop tools as well. And as I said, the mapping is virtual Earth. The catalog is data from, the maps are from USGS, EPA, and National Atlas. And currently we have data on dams, aquifers, geologic formations, watershed sensors, also ecoregions that are not listed here. And currently we are building a stream network based on NHD plus data set, so you will be able to move up and downstream on the river. And we have a metadata repository that contains information about measurements, when they were measured, the time frame, and what's being measured, the concept. Is it ammonia or E. coli? And as I said, we have 1.7 million sites, and each site can have multiple sensors. And for example, in the video, I showed you one site, and you could see the long list, maybe 20, 25 measurements. So the sensor count is a lot larger than the site count. And we scrape them on a regular basis. And this is how we take care of the semantics. We have a knowledge base that stores things in RDF tuple format. It's not a very complicated ontology. We have just a few properties, like is a relationship is measured using and is related to. And we support the transitive, symmetric, and inverse properties. And inverse statements are pre-computed. That's also in a SQL database. And here is what those terms mean. So if I say nitrogen is a macronutrient, macronutrient is a nutrient, it will infer that nitrogen is a nutrient. Symmetric property, if A is related to B, B is related to A. And inverse is if macronutrient is a nutrient, nutrient is a broader term than a macronutrient. And we have related materials, as I mentioned, from definitions from many different sources, but the links to ITEST, this is Integrated Taxonomic Information Systems for Organisms, and for chemicals, we have links to EPA Substance Registry System. And data retrieval part, we don't host any data. We can host data, but for USGS and EPA, we don't have any data. We just have the catalogs, which are indexes of the databases. So we run the searches on the local system. That's why it's really fast. But when you want to get the data, we connect to the actual data source on the fly and reformat the output of their web interface and return it to you. Since everything is reformatted, you always get a consistent output. And on my last slide, we have lots of plans for the future. One is to have better support for as a publishing platform for data sources that are smaller. So we have 1.7 million sensors, but these are agencies like USGS, EPA, National Weather Service, etc. But there's a lot of data out there collected by individuals, citizen science efforts. We want to have that kind of data in the system. And we would like to make some SciScope functionalities available as services, so you can embed things like a plot from a data source from SciScope into your website. And we want to also leverage this as a tool for general consumer use, because if you think that once we have everything solved about the heterogeneity problem, now you have a value for a chemical and the units, and there are already standards literature about the toxicity levels. Is it carcinogenic? So you can have some kind of an application. Let's say you are about to jump into a lake, then you go like, oh, let me check what the quality is like. And from the GPS on your cell phone, you connect to SciScope, and it gives you some report on the water quality. You get the values. At the same time, since you have reference material, you can get some qualitative analysis, kind of pass, fail, red, green, etc. And since we talked about publishing, there will also be ontology editing online, so we will have more collaboration tools. And at this point, I think I'll finalize my talk. If you have any questions, we have time.
So, if I want to, suppose there's a site that has 20 variables that I'm interested in, and I go there. I mean, do I have to get each of the measurements separately and then put them into Excel, or is there an easy way for me to specify all of them at once, and then I've got a table that has all the correlated variables?
Okay. When you do the search, it gives you things that are related to your search, in that search box.
Yeah.
And currently we don't have it, but we are going to have one download option that will allow you to add everything into one spreadsheet. Good. But you will have different pages. So you will have one page that has ammonia nitrogen, the next one will have nitrate nitrogen, for example.
That's fine. So you're saying that will be fairly easy to do?
Yes.
Good.
Yes.
Okay. It's not, I won't have to go and find this and find this and then just do some kind of a
No.
join on my own. That's all going to be taken care of.
Yeah, and it will be more like you won't even need to select individual sites. For
Uh-huh.
example, you will select an area which has 100 sites,
Well, so
and
now-
you'll get all of it. at
Yesterday
once.
we heard at least one talk on data integration for environmental sciences, and it sounds like this is going to do it all.
Okay, well, there is one issue here. We have 19,000 different kinds of
Sorry.
observations in the system.
Uh-huh.
And to have 19,000 different observations, there should be slight differences. So you're searching for nutrients. It knows that ammonium nitrogen is a nutrient, but maybe there are 10 different ways of measuring ammonium nitrogen. So there's still...
So there's still some issues about mapping things onto each other and stuff that the SciScope itself does not yet address.
Yeah, well, we have one reason to do that. For example, if you get data from EPA Storette, you're not going to have much information about the observation method. So I can't say that this is compatible with some other measurement because I don't have that information.
So right now you can integrate all the data easily, but you don't necessarily trust the integration.
Yes, that's why we have a two-step process. We suggest to scientists, these are the observations, this is the available metadata.
Okay.
Are you interested in this? If yes, download it. If not, your choice.
Okay.
We don't rely on us. We just provide the information system.
I had a question. Yeah, I had a long walk from the back, and I didn't feel like yelling. So one of my interests would be, now that we have this ability and we're collecting data, and I believe you showed a demo of SciScope where there was real-time data updated recently.
Mm-hmm.
Are you thinking about web services where you could come in and schedule, I would like data
Mm-hmm.
of these types provided to some access point that a model that I created could query on a regular schedule to create an updated forecast for the next condition, and I want this to run until I tell it to stop.
Okay, yeah. We have a desktop tool in the making which we refer to as a subscription tool. That will allow you to subscribe to a data feed and get incremental downloads as the new data becomes available. And the second part of it is, instead of registering, subscribing to a site, you can subscribe to data from an area. Let's say you're interested in a watershed, and the topic of interest is nutrients. So if there's a new sensor in that area that appeared after you queried the system, and it measures nutrients, you will get a notification that there are new sites. Are you interested in downloading? So it's not just a download, but also discovery as you go along.
But from the standpoint of modeling, if I want to automate this process, it's 1 a.m., I'm home and I'm sleeping. I want this to be done. I don't want the format or the order to change, because otherwise, when it comes to my computer, which is stupid computer, it'll say, well, there's 6 columns instead of 5. What do I do here? My results turn out to be quite funny, and I miss predicting that the water quality is unacceptable for swimming tomorrow, and the interested parties say, why did you mess this up?
Okay, so your question is not about subscriptions or downloads. It's more about the format and the web services.
It's about both, right? Because I would like to, if I want to do real-time management or something like that, I'm going to need to be doing a model that runs, with the most recent data as the conditions change. So I'd like to receive some product. I say I need these data provided to me, and I'm not sure of any facilities out there that can take data of unknown format and put it into the input format that I would expect. So I can do my own manipulations to it without having somebody to see it and to manage it.
Well, in our case, there is no unknown format because we have wrappers on top of each data source, and we know the format, so we convert everything to a common output format. So you will have a consistent output.
Right, but if you add a data source, that would be, to me, an unknown format.
No.
Because I would need to know which,
But you will still see the same output because we have EPA and USGS, but the output is the same 2 columns, the same file format, same indicators. If you have less than, greater than, one calls it LT, the other is a less than sign. You will always see a consistent output. I can add 10 more data sources, but since I take care of the mapping in the system, you will still see it like something that comes from USGS or EPA or.
Right, but where it comes from, what it is, in the model calibration itself, you don't want to put data from a sensor. It might be EPA sensor, but it might be a different one than you've calibrated for. You might get a very different result. That's what I'm saying as far as difference.
Okay, well, that relates to the first question then. We don't guarantee things about sensors. We just provide you with the options. It's like you do a web search. It gives you a bunch of links. You don't really know that is exactly what you want. But you have the title, you have the description. Based on that, you make your decision on whether you want to click it or not. Right?
So then it sounds to me that as far as automating goes, it's not really that easy.
Well,
I mean,
you need to make a decision whether you want to use that piece of data or
If I wanted to automate
not.
an iterative process, it wouldn't be that easy. But I can catch up with you later.
Okay.
To let more time for questions. Thank you.
Thank you for the question.
So are all of the data that you're putting out site-specific data? That is their point measurements?
Currently, that is only point measurements, but we have support in the system for moving sensors, like there could be aerial measurements. We also have what we call a mosaic data type, which is rasters. You provide a bounding box, but inside you have a raster image. And we store them as two-dimensional arrays. So in its current state, it has to be quadrilateral, regular grid, so everything has to be squares. But, we take care of that.
Okay. And are you outputting things like drainage basin boundaries if people
Yeah,
want?
it's already in the system. And if you use the site, you will see that it's also sensitive to the zoom level. So if you zoom out, you will see hydrologic region. If you get closer and closer, you will see subbasins. And that's how we do the query. You select the region, you see some information about that watershed, but at the same time, by clicking on it, you set it as a bounding polygon for your query. So you can say, I want all this kind of data in this basin, or in this ecoregion, or in this aquifer. It's already in there.
Okay. And then what about support for different projections?
Well, good question. So far, the only projection we have is Mercator, since that's what Virtual Earth supports. And as the spatial reference system, we use WGS 84. We may look at it in the future, but yeah, we make sure that everything in the database is in the same projection and same datum to make it easier to do the processing.
And that concludes our session, so thank you for coming.